essentially looking for the shortest path between two nodes in a directed graph. So this example is the second test case. We will go through the algorithm. So this is a well-known algorithm. It's Dijkstra's algorithm. So you can look that up. Okay, so I've drawn the graph already to save some time, and we are trying to find the shortest path from node 2 to node 3. So what we are going to do for this question is update three things. We are going to keep a list of the shortest known path from 2 to each node. So we will have a list of these nodes. So we have nodes 0, 1, 2, and 3. Initially, the distance from 2 to itself is 0, and the distance to each other is infinity. And we have two other pieces of information. We have the current node and the list of visited nodes. And the current node is 2. So the first thing we are going to do is look for the edges that leave node 2. And we see there is an edge from 2 to 1. And this has weight 2, which is shorter than the current known path of infinity. So we update the shortest known paths. And there is an edge from node 2 to node 0, which has weight 1. So we update this. So now the shortest known path to 0 from 2 is 1, and the shortest known path from 0 to 1 has weight 2. Okay, so we have run out of edges from node 2. So we change the current node, and the node we choose next is the one which currently has the shortest weight and which is currently unvisited. So we are done with 2, so we add 2 to our list of visited nodes, and now the current shortest path is to node 0. So the current node is now node 0. So we look at the paths from node 0. We see there is a path from node 0 to node 3, and this has a weight of 3. So this means that we now have a shorter path to node 3 than the currently non-existing one, which has a weight of infinity. So the weight of this new path to 3 from 2 is the current shortest path to 0 plus the weight from 0 to 3, which is 4. So we update this. And now we want to check the other path. There is a path from 0 to 2, but this weight is bigger than the current known path from 2 to itself, which has weight 0. So now we are done with node 0. So we add 0 to the visited list, and we move on to the next node. The new node is the one that currently has the smallest weight that is not yet visited, which in this case is 1. We look at node 1, and we see that there are no edges exiting 1. So we are done with 1 immediately. So now we have visited 1. And now we move on to the next node. And now this node is the one which has the lowest score, which is now 3. Now we can stop because we are not interested in any paths exiting 3, because 3 is the node that we are aiming for. So then the final answer is the final entry for the shortest known path to node 3, which is 4.